So now we want to do a quick revision on what we call the linear motion. Linear motion. When you say linear motion, a body is said to perform linear motion when a body changes its location along a straight line. Let's say for instance, come and look at it. So let's say for instance, we have this ruler to be a straight line or a straight path. So as and when this car is moving along this straight line, along this straight path, then we say that the body or the car is performing linear motion. As the body is performing a linear motion. Now, you see, when we talk about linear motion, there are quantities, very important quantities that we need to know under linear motion. When we talk about linear motion, then it means that 1, we should understand distance. 2, we should understand displacement. 3, we should understand velocity. 4, we should understand speed. And 5, we should understand acceleration. Let's have a quick revision on the definition of these very important quantities. When you say distance, then distance talk about it is a separation between 2 points. So let's take a look at this straight path here. This point to this point can consider to be a distance. This point between this point can consider to be a distance. We also can talk about displacement. Displacement is you are covering a distance in a specified direction. That is, this time around you are moving on a distance, but this time you are heading towards a specified direction. So let's say when this car is moving a displacement, it is heading towards, let's say, east. So we can say that this car has covered a displacement. When you talk about velocity, velocity is the rate of change of displacement with time. Speed is also the rate of change of distance with time. Then let's come to the acceleration. Acceleration is what? Is the rate of change of velocity with time. Now let's quickly come to this application question under the linear motion. Let's read. A body starts from rest and accelerates at 3 meters per second square for 4 seconds. Calculate the final velocity and the displacement of the body. So in general, what we are finding from this question, first, we want to find the final velocity. Second, we want to find the displacement. So in general, when you want to find these quantities or these parameters, then we shouldn't forget what we call the Newton's equation of motion. They are very important equations that will help us to solve linear motion questions, right? So let's remind ourselves. First, Newton's equation of motion is v equals to u plus at. Second equation, s equals to ut plus half at squared. Third, v squared is equals to u squared plus 2as. Now we know v, let's consider v to be the final velocity, u the initial velocity, s displacement, a acceleration, then t time. Now, before you can solve this question, you need to know the parameters given in this very question. Let's remember, when you say a body starts from rest, the moment the body starts from rest, then it has an initial velocity of what? 0. So we can put it down. U is equal to what? 0. It has an initial velocity of 0. Now let's consider another quantities, another parameters that we have here. We have been given acceleration, so a is equal to 3 meters per second square. We also know time, t is equal to what? 4 seconds. Then what are we finding? We are finding the final velocity. V, we don't know. Then we come again and ask ourselves, which of these equations, the Newton's equation, that can help us to solve this very question? We can use the first equation. So let's put it down. V is equal to u plus at. So we already know that the u is 0, initial velocity is 0. Plus the acceleration is what? 3. So 3, then time is 4. So meaning the 3 will multiply the 4 and give us what? 12. So we are having the final velocity to be 12 meters per second. That has also helped us to find the final what? Velocity. Second, we are left with finding the displacement. We are left to find the displacement. So equation that will help us to find the displacement, we can use equation 2 and equation 3 because these are the very equations that we can see the x and the x here. And we can use it to find